At NASA, we dream big. Our projects that that are most interested in are the ones that sit on the launch pad that are 100 stories high, the big things, the multi-billion-dollar projects. CubeSats are seen as a great tool, a great vehicle, but something we're not ready to devote a lot of time to, but something we're interested in. So what NASA has done then is provided funds and some technical expertise, and we put it out there. And you just see what grows.
CubeSats come under the classification of small satellites, so by nature they're small, much smaller than regular satellites. The typical CubeSat, called the 1U CubeSat, is 10 centimeters by 10 centimeters by 10 centimeters.
This is a CubeSat. This is a perfect replica. Normally at NASA, you're going to see models and it'll be like 1/5 scale or 1/25 scale or something. This is actually 1 for 1. This is the size that my preferred technologies go into now. This is called a 3U CubeSat.
CubeSats occupy what is called low Earth orbit, or LEO, same as the International Space Station. Typically their altitude is a couple hundred miles, and they eventually decay in their orbit and burn up on entry. And they can stay in orbit anywhere from perhaps weeks to months at a time before burning up and re-entry.
We open this up, it's closed off. It's got a hatch on the other side as well. So it's at ambient temperature or pressure and temperature. So we open this up, we slide the experiment tray in. It could be CubeSats or other experiments that go in there. Then we seal this off and we take it down to vacuum. And then we open up the hatch on the other side. We can do it robotically. And we have an arm out there. We can reach in, grab this tray, and just kind of point it towards wherever we want to launch these things.
We have the primitive CubeSats, which just do something very simple, like take photographs of the Earth, very simple missions. But in the future, it could be much more exotic missions.
The interest from academia primarily has grown so much that it's exciting to see what's going to happen. Because when you have a limited pool of parties interested, you get the same thoughts over and over. When you have 300 people respond to it, you get a lot more diversity in thought.
The University of Houston is a relative newcomer to the CubeSat field, but we're very excited about it, and we're really kind of hoping to ramp up in the future.
So we're working with Texas A&M AggieSat Lab. They're actually building a 50-kilogram satellite that's going to go up into space probably this year, early in this spring. The satellite's actually much larger than kind of your Cube satellite. It's actually a 50-kilogram satellite. It's got several missions that NASA is actually conducting that's going to try to help small satellites in low Earth orbit basically track each other and dock with each other and be able to know each other's relative position in space.
So the main plan is to have the two satellites separate and then fire the thruster and have them come back close together, not actually rendezvous and touch. That will be the third mission.
They've got many different subsystems on the satellite. They've got the power, they've got the solar cells, they've got the actual mission, and they need help with many of these different pieces. What we've taken on is the visual data capture system. So we're building a system that's going to actually take pictures of several events once the satellite's in space.
The whole reason that VDCS is necessary is because Lone Star's first mission, they never detached from each other, and there was no actual visual data or evidence to see what was going on there, what occurred to fix the problem.
Not long after we started the visual data capture system, they said, well, we would also like for you to work on ground support communications, the method for interfacing with the satellite once it's constructed. So on top of the visual data capture system, we also built the ground support communication systems.
A big part of my motivation is I want to have a picture on my wall that I can say I took a picture in space. I had a part of that.
Presently, CubeSats use off-the-shelf technology which means they have fairly bulky wire antennas sticking out of the CubeSats, just for example, as you might see on your car. And although it works fine for your car, it's very delicate to put such an antenna on a CubeSat because these CubeSats have to be deployed from a rocket, and normal wire antennas are subject to breakage when they deploy, and they're less reliable than other types of technology that would not stick out from the actual body of the satellite. We've been working on with a technology called microstrip antennas, which is a type of antenna that is mounted flush right on the frame of the CubeSat and does not protrude from it, so it's much more reliable and less prone to breakage, for example, during deployment.
Basically, we need to put the antenna onto the surface of the satellite, which is there are some difficulties, like we need to make the antenna transparent, or we need to make the antenna very small so that we won't block the light onto the solar panel.
The challenge is because the material is also need to be transparent, and so all the parameters are fixed, kind of fixed about the height, about the area, and there's very few flexibility. We still need to do transparent antenna on those, so the antenna design is very important.
Yeah, Xinyu just designed a very great transparent antenna with very good performance. Maybe she can talk about that. Yeah, it's a really brilliant design. Yeah, I think.
All right. It's not very brilliant. It just works.
And the work was very well received at the conference, and in fact, they won first place for their contribution.
Just make me feel very satisfied when you can actually use what you learn on your project and make something out that really works.
Certainly CubeSats fulfill both missions, education and basic research. I think sort of the educational opportunities are almost obvious. Space is such an exciting area for students. They love the excitement of getting involved in a space program, to develop an actual functioning satellite, and then to actually see it go into orbit and perform its job. That's just incredibly exciting.
Imagine one day our antenna can actually go to the space. That's really exciting topic to it. Yeah, it's just, I can't imagine that before I go to this project, but after that, yeah, it's kind of a dream come true.